Monica Berrondo from MacroMoltek and Dennis Delacorte from ZONTAL, who will be presenting our first seminar today. Looks like you're all set, Monica. We can see your slides.
Okay, thank you very much. I'm very excited to be here and to present a little bit about this case study. So just want to tell you a little bit about MacroMoltek and why this was a case study that we were interested in doing and what we were trying to do with it. You go to the next slide. So what our vision is to change drug discovery to drug design, and we've been doing this through using software to address how new antibodies are made. So we use software tools to produce antibodies and then use lab tools to verify and validate those. And we've made an advanced AI platform that produces a lot of different designs that we can then test in the lab. Next slide. So we're in Austin, Texas, and we were the first company to computationally design an antibody. And we've been building these algorithms in-house, and all of these algorithms rely on a lot of data. So data from, decades of structural and sequence data, as well as data that we've gathered over the years and put together and that we work with to do that. And then we use a team of a very cross-disciplinary team that comes from different backgrounds. So not all of them know how to manage this data or how to use it in the same way. So having like a really streamlined way is very important for us so that everybody can have the same access to it. Next slide. So just really briefly about what we do and where all this data is coming from. So we use a combination of neural networks and structural modeling to produce tens of thousands of sequences of antibodies for each project that we do. So the first thing is we have these neural networks that assess the target structure. Once we've assessed the target structure, we use a really high throughput way of analyzing each of the places on that structure that have been identified as good places for designs. We use structural modeling to come up with new designs for each of those patches. And then once those patches have tens of thousands of designs to each of them, we have to post-process those and select down to a smaller set that can then be used for testing in the lab. And so along the way, each of these produces or relies on a lot of data. Next slide, please. So with those initial neural networks, the inputs that we have trained on rely on vast amounts of data and really taking that and filtering it and assessing it and making sure that that it is very nice and streamlined. Then that high throughput system that designs a bunch of antibodies produces data that must be stored and that we can go back and look at once we've assessed through experimental validation. So we have to be able to keep track of this and catalog it in such a way that it's very easy to go back and search through. And then finally, that last neural network produces even more data that we sort through and that we have to be able to combine with all the other steps. And then that experimental data, like I said, we're taking a small set that we're going through, that we're getting experimental data for, and what we need to be able to do is search that and then match that back to what happened through each of the steps to get here. So what we need is a nice consistent data pipeline which tracks from those earliest stages of those neural networks through the validated antibodies from the experimental data in order to continuously improve our algorithms and be able to keep track of every single step along the way. Next slide. And so with that, some of our current challenges that came up with this is how do we go back and search through that data? So we need it to be searchable and taggable and be able to preserve what happens across each project, and then go back and do cross-project analysis so that we can see when something works in one case, how can we correlate that with when it doesn't work and make sure that we have all the information that we need in order to do that analysis. And so that's where our work with ZONTAL came in. So I'll hand it off to you, Dennis.
Great, thank you so much for setting the stage, Monica. One thing that might be important to say at the beginning here is throughout this project with MacroMoltek, we didn't talk too much about Allotrope. And that might not be the nicest thing to say at a conference like this, but if we really think about bringing the value of Allotrope to customers, it should be more important to understand the business cases and which features of a technology support them than to educate on the technology itself and then have the customer decide which parts of it might be most suitable. So from the vendor perspective, we thought it very important to understand what the business cases were, and then to do an analysis of which features from the Allotrope model, as it is currently supported within ZONTAL, can be best suited to bring the most bang for the buck. And so what we thought is that there are different schools of thought currently around Allotrope and how it can be leveraged. And we have heard it in the different presentations, and we guess we're gonna hear more about that today, that you can really tackle the idea of using Allotrope productively in a variety of flavors. And one of them that we probably spent quite a bit of time on in the past is the idea of building complex ontological graph models. And while this is something that's intellectually very stimulating, and it's a great idea to represent the entire universe around a data point, it is also something that takes a lot of time. And so there's a trade-off in between getting to the final product and the effort that is necessary of achieving this that has to be met. And so one thing that we found in ZONTAL throughout a variety of projects now is that actually building tabular models instead of complex ontological graphs creates a more dynamic, faster process with the SMEs, so the subject matter experts, and helps us to get quickly to the converged vocabulary and controlled terminology that helps us to annotate the data meaningfully and in preparation for a more complex ontology down the road, but it gets us really quickly to the point where we can start leveraging some of the semantic powers without having the very long pre-project. So tabular models seem to be something that work really well for that. But then something else, of course, is the question, what do you focus on for data representation? Do you want to convert everything into a data cube? Do you like an RDF representation of raw data? So the thoughts diverge there quite a bit. And while it might be a good idea to put everything into the data cubes without the semantic description around it, we kind of run the risk of creating long-term readable data, but that's not really findable and accessible anymore. Well, it's accessible, but not necessarily findable because we don't really know how to find it after we have created a very large amount of those ADF files that just contain data cubes. Another thing we have seen and done in the past is to just sort of abuse ADF as a zip folder on steroids and just say, I can just wrap everything inside of an ADF file and then leverage the audit trail around it so that the data package is filled, the audit trails keeps updating, so I have sort of a limited genealogy what happened to the data, but there's no semantic integration happening. We're not contextualizing the data, we're not doing any long-term representation. So while this gets you an instant ADF, it might not be the thing that gets you really what you want in terms of fair data down the road. And then finally, something that we have observed now at a couple of presentations in the past is that some companies go the way of ignoring semantics altogether and just say, hey, let's just use a different type of data abstraction like a JSON file and postpone the creation of ADF to the point where we actually understood the business case sufficiently to know what type of semantics are meaningful. And that honestly is something that's very easy to do, right? We can just do a data abstraction on something and then go ahead and implement it. But I don't think it really meets the core criteria of what an allotrope solution should look like. So what we did within ZONTAL, and what I think is really the two unique features that we bring to the market, is that we made it possible to productionalize the ADF generation and reuse. And so after we understand the business cases and the business values that can be potentially derived from any type of data set, we can leverage the ingest pipeline of ZONTAL to do the data verification. And what that means is that based on the demands and the requirements of the user, we can decide how we want to structure the allotrope data file that is being produced, which is we call it now a self-reporting data asset, a fair data representation of the data that came originally in. And so what we're able to do in this pipeline now is we can, for example, create on-demand ontologies. So if you have the process where the SMEs give you some basic idea of what fields are important for a data model, but they don't really want to go through the long effort of defining it all in a holistic way. And if it's the first proof of concept within a company, which currently is happening quite a bit with Allotrope, we do not need to anymore go through long rounds of iterations. We can just build within the ZONTAL space architecture ontologies that are built on the fly, and that will then be available for future data models for reuse. And so we found that that is a very scalable and quick way to bring Allotrope to the people. This is, by the way, what I presented 6 months ago at the Allotrope Connect, and this feature of data verification and creating Allotrope files on demand is something made available for all members of the Allotrope Foundation. So that's something we just offer as a service. So if you haven't had the chance yet to explore it, please reach out to me or the rest of the ZONTAL team. We'll be happy to help you create some Allotrope files to see how this works. But once we have these self-reporting data assets, then really the second important technological advancement of ZONTAL comes in, and that's what we call the democratized data access. I hope you had the chance to listen to the Novartis presentation on Monday. If not, I really encourage you to go and review it as it becomes available on a YouTube channel, because it was a really nice presentation from a data scientist perspective of what it means to democratize data in a digital integration hub. So in their case, it is a ZONTAL installation that gets them the ability to do high-performant SQL searches on all of the Allotrope files, and to be able to actually query and search a large repository of Allotrope files with something as easy as a SQL query is something that you can't find anywhere else yet. And so we believe that by putting ZONTAL into, for example, a biotech, we are able to take any data set, upgrade it into a self-reporting data asset, and then enable access to it that powers business processes, enables new data visualizations, and then gives you advanced analytics abilities. And for Monica and MacroMoltek, it's obviously a big deal to store data for future training iterations of machine learning networks, to make predictions with it, but then also to learn how to best analyze across an entire product life cycle. So I think in summary, it's really nice to know that with ZONTAL Space, you can have a digital integration hub that really produces Allotrope files on demand. Doesn't really matter if you have a data model completely defined. If you have an ontology in place, we can create one very rapidly, and then we can deliver that in a meaningful way to the customer. And in the case of MacroMoltek, they didn't even need to know that Allotrope is under the hood. All they needed to know is that there are benefits that come from it. So if we look at the concrete proof of concept that I want to demonstrate to you, which is a subset of the things that we have done together, is here a workflow that is currently or was until recently implemented in MacroMoltek. So before ZONTAL, what they did is at the very end of this computational pipeline that Monica presented, they're running the experimental validation. In this case, it's called an Elisa Essay that just measures how good these new designed antibodies actually work. And at the end of these essays, what you typically get is an Excel file that contains absorbance values for a well plate. So you have a table representation of this, would be here like a 6x3 matrix, in which each of these representative cells would have an absorbance value. And that is stored in an Excel file, and it's extremely non-self-reporting or unfair data. Because you only get an absorbance value and you have no idea what went on with the well. So everything that happened in the experiment has to be stored either in an ELN or in their case in a different tool that produced a JSON file. But given that you have this data in Excel, in the past you were able to run an analysis on that individual sheet, and then you could make some plots that help you to inform how good the data was. What we did in this proof of concept is we went in and said, hey, let's take these well information, so these absorbance values and the corresponding metadata about the experiment, and map them with ZONTAL to an ELISA ADF model, data model. So this data model took about 2 hours to create with the subject matter experts together. So it was a rather rapid process. And then with that in place, we could instantly go in and ingest the Excel files and the corresponding experimental information, map it to the ADF model, and then make it again accessible through ZONTAL for project-wide analysis. And so the ability now to not only take data in the context of one Excel, but completely out of context of its individual measurement, but in comparison with all the other data points that were created to run a project-wide analysis was really the new thing that we provided, and I'm going to show that to you in a live demo in a second. So the one thing I still wanted to show, though, is what we mean with creating self-reporting data sets or data assets is really this mapping, where you have the Excel representation of absorbance values, you have then this JSON-based experiment description, you throw that into ZONTAL, and it creates you a nice ADF where all the information is simplified and RDF, and you can run really performant and SQL searches on top of this. And so this is what I plan to show you. Of course, live demos have their catches, so please press your thumbs that this will work out. Could I get now? Yep, there it is. So, no go to. Here is ZONTAL space. I will probably need to log in again. So what I did here is on our front end, I'm looking for all the data in the system that's connected to Elisa. Right now we have 2 examples loaded. So when I bring them up, I can see that here, for example, the cells from the Excel sheet and then the corresponding absorbance values. And I have 2 of these examples here. What we have now built, and that's a new feature in ZONTAL, is the SQL interface that allows you to connect systems like Qlik or Tableau very rapidly. In this case, we're using Redash to build queries on top of the data. So what I'm showing you here is how you can build rapidly a visualization of the data within ZONTAL space. So first, I'm looking for all of the Elisa data that is here. And I can see that there's quite a bit of different metadata tag that comes from the data model. And I can go in here and just do some basic SQL code. So I can, for example, select everything from, and then I'm just going to grab these Elisa results. And as I execute this query, it's going to pull in all the metadata that is currently available for the 2 data sets and puts them then in this table. So I can see quite a bit of information here that may or may not be accessible to me. So what's really powerful instead is to create some visualizations. So I can go, for example, here and let's go and create a scatter plot where I put maybe on the x-axis first, let's put the cell ID and see what happens, and on the y-axis the absorbance. So I can see right now what type of absorbance values I have, but cell ID is not really a great X value. Maybe we can use instead the variant. Oh, they're all not the antigen. That's the project name. Let's take the variant name instead. The variant name, and then I can see that I have 2 variants. One is called prior +4 and one is prior +6, and they have different absorbance values. Another thing I could do, of course, is just create some scatter plots between, for example, something that we derive from these absorbance values are the EC50 values. They are something that ZONTAL extracts on the fly from the data that is created, and they help us to analyze further how these absorbance values actually reflect the activity of a given antigen or antibody. So let's give this guy a name. Let's call it a scatter Elisa demo and save it. Something else we might want to do is if we look at the table here and see, oh, we don't really like the representation because the content identifies something we don't really care about, then we can go in and just drag this down and maybe put the antibody on top so we have the names there, and then save this. So we can rapidly adjust the way things are visualized. Maybe something else we're interested in is a bar chart where we look at how the different antibodies perform with respect to, for example, the absorbance or the EC50 or some other values that are related to this analysis are the midpoints and the inverse EC50s. And we can do this to create now something you might want to call the Elisa Bar Chart. Okay, now after I've created these visualizations, I can give this whole thing a name and call it like the Elisa Allotrope demo and save this. Oh, didn't save the name. Elisa Allotrope demo. Always hard to spell when so many people watch. Okay, and now what we can do is we can go in and create a dashboard based on this. So and that's really where I think the power comes in of using these SQL queries, because after we have once created one of these queries, we can go in and just say, hey, let's just build us something that's not an ad hoc analysis, but something that's more persistent and that we can use in the future and maybe even share with some of our colleagues. So I'm just going to click together here the 3 visualizations. And after they're in, yeah, so this is saved. So now we have this dashboard and we can kind of browse through the data. We can look at the visualizations and we can see how across the different Excel files, so across the different experiments, variants perform. And now what makes this really powerful is if I go back into ZONTAL space and say, hey, let's increase the amount of data that we have by ingesting another example. So I have a different example file here. And as I load this into ZONTAL space, it now takes this raw data, does its conversion. So it takes a moment to get shipped here from Utah, where I'm located, to our server in Germany. Then all the data is being extracted, the ADF file is generated, the triples are created, and as soon as they're there, we are going to promote this file. Now it's done into the archived state. And now we can see that we have data extracted for it. So as I go now back in here and we're done editing, I can just click on refresh. And now this is really the power of dashboarding. Now all of these visualizations are going to be updated. So the SQL query is now running in the background. And now we're done. And we've seen a few more data points pop up here. And we have seen that this prior +5 now showed up. One thing that we can notice is that apparently the inverse EC50 is a very, very large number. So something fishy must have gone on. As I click on it, I can see that this number is like in the, don't even know what it is, quadrillions or something. So we're probably we probably have a data issue here. And having a dashboard like that might motivate me to go in and check the data that came from this experiment and to find out why the calculated EC50 values are this bad. And just to show you that the rest of the data is all right, we can go back into the queries here and take the Allotrope demo that we just created and take the bar charts, edit it, and throw out that EC50. And then we can see that the rest of the data actually looks more reasonable. So this just demonstrates how dashboarding can be used to monitor data. But what really will bring the biggest benefit to a biotech like MacroMoltek, and we can go back to the slides now, if that's okay, Jamie. Matthew, can you go back to the slides, please? Does this work? Okay, so what we really see as the main benefit going forward is by creating these allotrope files on demand and powering visualizations, we're doing one of 3 things. The other 2 things are powering business processes and providing deeper advanced analytics. And so down the road, we can really see that all of these allotrope files that are going to represent not only the experimental values, but also the computational results, like the machine learning models, the created structures, the sequences that were designed, all those will become self-reporting data assets. And then within ZONTAL space, we can make sure that they're always available and preserved. So if you want to retrain a model in the future, the data is always there. But then we can also enable cross-assay analysis and to be able to compare then not only the experimental data by itself, but experiment with computational prediction, we'll be able to really advance the analytical abilities of biotechs like MacroMoltek. And so going forward, I can really see that Allotrope, the Allotrope data format has the potential to bring high value to biotechs, but they don't necessarily have to know what the Allotrope format is. We can just sell really the business benefits to them. And with this, I thank you for your attention.
Great, thanks, Dennis, and thanks, Monica. Do we have any questions for the presenters? Just a reminder that you can type them into the chat window, or you could also raise your hand using the virtual raise your hand button. Obviously, you could raise your hand at home, but we probably wouldn't be able to see you. Maybe to get started, I just had a question. So the ELISA model that you showed, right? So this is a model that you're developing essentially in real time, right? You know, how difficult would it be to take that then and to get that, you know, in as a fully governed allotrope data model?
So I think we would have to discuss it with is there a working group for that? I'm not sure what the process is, but we can definitely make it available and share it. And I would say it is a pretty solid model, so we should be able to elevate it to something that can be made accessible through the Allotrope framework rather rapidly.
That sounds great. Yeah, just to answer your question, right, we have, you know, aptly called the modeling working group, right, that has been working through a lot of the tabular models, right, that you mentioned. And so, you know, it would be great to have an ELISA model be a addition to that.
Yeah, we can definitely follow up with that. Mm-hmm.
Mm-hmm. And so, hey, Dennis, it's Vinny. So a related question to that, yes, definitely encourage a submission. We can talk about that offline if that's of interest. You demonstrated rapid ADF creation for your tool. Can you also comment on whether the tool, when developing those ontologies on the fly that are necessary and then the data model with it, does the tool do anything to check conformance with style guides, reuse of terms, term placement, anything that really gets to the quality of the ontology as part of the ZONTAL space tool that you made available, or is that a manual process at this point?
So we have a pretty sophisticated pipeline that is able to tie into existing ontologies. So at this point, we will not create a term that isn't already existent, for example, in the Allotrope published ontologies. So they will be used if there. With regard to adhering to style guides, I have to refer to Wolfgang, who architected this. So I'm pretty sure that he will follow the style guides, as I think he was one of the main contributors to them in the first place. But we can maybe follow up with a written response to that question later on, if that's okay.
Yeah, that would be perfect. Again, it would be useful to if you could just send it to the community, just so if they do make use of the tool that you've made, that ZONTAL has made available, just so they are aware of what's going on behind the scenes. Thanks.